All right, we've got an example problem to do here, but first I want to review a very simple math skill. Right here we have 2y plus xy. Just a reminder that you can divide both of these by y. You can factor out a y with this format. Since there's a y in this term and there's a y in this term, you can pull the y out. It's like the opposite of a distribution. You'll have y 2 plus x. So this skill of factoring will be used here. Just wanted to give you a reminder. Here's the example. Take a quick pause and write it down. We're going to calculate the common velocity of the two-car system after the collision. So this is what I was talking about when I was talking about systems. The system here is two cars. If there were a third car that came in and bumped them, then that would be considered an external force. We also have the force of gravity pulling down. You might think that's an external force, but it's being balanced by the ground pushing back up. So although we have the external force of gravity, it's being canceled out by that upward force, so we can still use the conservation of momentum here. Our external forces add up to 0. So what we have is a 92,000 kilogram car moving with a velocity of 1.3 meters per second. It catches up to a 65,000 kilogram car which has a velocity of 0.8 meters per second. They collide, they stick together, and then they move on to the right at the same speed. We'll use the conservation of momentum for this, as we will for the remainder of the week. Here it is. We're going to use the expanded version. So m1 v1 f plus m2 v2 f equals m1 v1 initial plus m2 v2 initial. So right away, I'm going to go ahead and use the factoring skill. Before I do, take a look, see if you can guess where I'm going to do it. Which of these, we have 8 values here. Which of them are exactly the same? Now, of course, M1 and M1 are the same, but we can't factor those because the equal sign is here. So I mean, on this side, are there any 2 values that are the same? On this side, are there any 2 values that are the same? And the answer is these guys. V1F and V2F are the same. V1F is the final velocity of car 1. V2F is the final velocity of car 2. So at the end, since they're sliding together, they're attached. That means that their velocities are going to be the same. Just so you're following, just to make sure you're following along here, I'm calling this is car 1 and this is car 2. So if we look at our before picture, V1 initial is 1.3 and V2 initial is 0.8. So we're going to do this factoring and then we'll go ahead and solve. So like we did before, those are the same, so we're going to pull them out. It's like I said, reverse distribution. But we need to give them a different name. Like over here we had I've lost my little post-it, but it was y. The name we can give to these is just VF. We don't need to differentiate between V1 and V2 because the carts now have the same velocity. So we'll just call it final velocity. So VF, M1 plus M2, and we'll just write down the rest of it. M1 V1 initial plus M2 V2 initial. If we do any quizzes in the future, I'll provide this equation up top, and I'll also provide this equation here, so you'll know, like you'll have the options, so you won't have to spontaneously know to distribute out. But you should be able to pick this equation because it only has one VF. It indicates that these two are moving together. Anyway, let's plug in the rest and see if we can solve. So VF, M1 is going to be 92,000. M2 is 65,000. Once again, we got M1, so it's 92,000. Make sure you don't mix up your velocities here. So V1 initial, you gotta make sure you put the proper one, and that'll be 1.3. So this is kind of cool. That term right there, well, let me finish writing. So M2 is 65,000. And then V1 initial, or V2 initial is 0.8. So I kind of like the way this is set up. Each term has its own meaning. This here, like I was saying, 92,000 times 1.3, that's the momentum of this cart before the collision. 65,000 times 0.8, that's the momentum of this cart before the collision. And this term altogether represents the final momentum of the whole system afterwards. And what's more, adding these two together gets you total momentum of the system before the collision. And that shows that they're the same. So our total momentum before is the same as our total momentum after. Pretty cool. So we'll simplify a little bit. We'll add those two together. 157,000. I'm not super confident about that. Yep, 157,000. We'll take 92,000 times 1.3. Well, actually, we could just type that in our calculator all at once. 92,000 times 1.3 times 65,000 times 0.8. I'm gonna check my work here. Whoa. 171,600. And now we just divide both sides by 157,000. So our final answer, it's around 1.09. I kind of want to get a more exact answer. Ooh, snap. There we go. 1.093. So there it is. If we have a cart that's 1.3 meters per second, we have a cart that's 0.8. Basically, this one's going to slow down a little bit, or this one's going to speed up a little bit, and this one's going to slow down a little bit. And so they'll have a momentum that's in between. So that's our final velocity. And that's about it. We'll look at some problems in 2 days. And yeah, talk to you soon.